Exercise 3.19, problem 21 to 25 solution. A quadratic equation whose one root is 3 is one of these equations. So the easiest way is substitute 3 in all these equations and see which equation proves true, and that equation is the one which we need to select. Okay, so substituting x equal to 3 in various options we get. So first one will be 3 square minus 6 into 3 plus 5. And this will be 3 square plus 6 into 3 minus 5, and this will be 3 square minus 5 into 3 minus 6. This will be 3 square minus 5 into 3 plus 6. So what we did, we evaluated all the options and it was only the D option which led to 0. So basically the equation option D is the right one, because all these things led to some numbers, see 22, whereas B is right answer is 0, so which means this is not right. Right, and in the option A we got the right answer is minus 4, but whereas it is 0 here. Similarly, for option C we got C equal to minus 2. It is only for this option D we got the value of the right hand side correct, which is 0. Therefore, this is the equation for which 3 is a root. Okay, next one. The common root of the equations x square minus bx plus c equal to 0 and x square plus bx minus a equal to 0 are, they have given us 4 options. If there is a common root, what does it mean? That root, let alpha be the common root, and that alpha will prove both the equations, right? True. So if I say alpha is the root of this equation, then alpha square minus b alpha plus c will be equal to 0. Similarly, alpha square plus b alpha minus a will be equal to 0, because it's a common root. Any root, if you substitute in that equation, it will prove that equation. That is a key point you'll have to remember. So let's substitute alpha. So this will become alpha square minus b alpha plus c equal plus c, and this is alpha square plus b alpha minus a. Both are equal to 0, right? When you substitute alpha, which means they will be equal, right? So I'm equating alpha square minus b alpha plus c equal to alpha square plus b alpha minus a. And if you look at it carefully, so this alpha square and alpha square will cancel off, right? And this will come plus 2b alpha, and this, when it goes to the other side, it will become okay, so I'm just bringing it this side, so it will be 2b alpha and c plus a, or alpha will be c plus a by 2b. So that is c plus a by 2b is option A. Right, please understand this. Since alpha is a root, it will prove the equation. So alpha square minus b alpha plus c will be equal to 0. Here alpha square plus b alpha minus a alpha minus a will be equal to 0. But both are equal to 0. So I can equate this to this. Am I right? So that is what I've done. So alpha square minus b alpha plus c is equal to 0, and that is equal to alpha square plus b alpha minus a. I've just missed out this here, because as I said, both are equal to 0. After substituting alpha, these two LHS will be, both the LHS of these two equations will be equal, and that I've done here. Okay, then after that is basically simplification. Alpha square I'm cancelling, and I'm collecting all alpha terms to one side and the constants to the other side and simplifying the expression. So understand this. So whenever alpha is a common root, the LHS of both the equations also will be equal. Okay. Right, next is 23, problem 23. And what does it say? If alpha, beta are the roots of ax square plus bx plus c equal to 0, a not equal to 0, then the wrong statement. So you have to quickly, for this you have to do a lot of simplification, but quickly go through, you'll be able to get that alpha plus beta, alpha and beta are the roots. So alpha plus sum of the roots is minus b by a. Here you can see they have put it as equal to b by a. It should be minus b by a, right? So this is the wrong statement. So we know when alpha and beta are the roots, alpha plus beta is minus b by a and alpha beta is c by a. Therefore, this option C is wrong. Right? So alpha beta is given as b by a, which is wrong because it is equal to minus b by a. So this is our wrong statement. Okay, so now let's go to problem 24. If alpha and beta are the roots of this equation, ax square plus bx plus c equal to 0, then one of the quadratic equation whose roots are 1 by alpha plus 1 by beta is, they've given us 4 options. So basically, so let these are the roots, so you'll have to find the sum of the roots, product of the roots, and then use the formula. What is the formula? When you have the root, sum of the roots and the product of the roots, the quadratic expression is x square minus sum of the roots into x plus product of the roots equal to 0, right? So that's the method we'll have to do. So let's sum of the roots is 1 by alpha plus 1 by beta, because these are the two roots they have given us, right? So they say these are the two roots. So sum of the roots is 1 by alpha plus 1 by beta. But since alpha, beta are the roots of this equation, we know alpha plus beta is minus b by a and alpha, beta is c by a. We have that values, right? So this, in simplify, you'll get alpha, beta, and the numerator you'll get alpha plus beta. But as I said, alpha plus beta is minus b by a, alpha, beta is c by a. So this a and a will cancel, so you'll get minus b by c. And product of the roots is 1 by alpha beta, and alpha beta, if you substitute as c by a, this on simplification will become a by c. It's a fraction by fraction, right? Now we have the sum of the roots and the product of the roots. Therefore, the equation is x square minus sum of the roots into x plus product of the roots equal to 0. So this minus of minus will become plus, and you multiply both sides by c. So this will become cx square plus c will cancel off, so you'll get plus bx, because minus into minus will become plus, and the c will cancel off, you'll get plus a. So the equation is, on the right side, if you multiply with c, 0 into c is 0. So cx square plus bx plus a will be equal to 0. So this is the option. So which option is that? Cx square plus bx plus a equal to 0. This is option C, right? Next, problem 25. So let b equal to a plus c, then the equation ax square plus bx plus c equal to 0 has equal roots if. So basically they say ax square plus bx plus c equal to 0 has equal roots, and there is a particular condition which needs to be satisfied. So we know when the equations have got equal root, then b square minus 4ac is 0, right? The discriminant is 0. So b square minus 4ac is 0. But at the same time, it's given b is equal to a plus c. So substitute that here. So this equation will become, right, a plus c the whole square. In the place of b, we are putting a plus c. So this will become a plus c the whole square minus 4ac equal to 0. Now expand this. So this is what? A plus b the whole square formula, right? So a square plus 2ab, that is 2ac, plus b square minus 4ac. So this will become a square. This plus 2ac and minus 4ac will become minus 2ac, and c square will come as it is. And the right hand side, let's carry forward that it is equal to 0. But what is this? This is a minus c the whole square, right? So taking square root, you'll get a minus c equal to 0 or a equal to c. Therefore, the roots are equal only when a equal to c. So a equal to c is option A. You got it? So basically the roots are equal and b square equal to b square minus 4ac is 0. They have given the value of b as a plus c. Substitute that, simplify it, and you will get one final expression, and that is one of the options. Okay. So I hope it's clear. If not, please go through this one more time. It will become clear. Thanks for watching this video.